All right, guys, so this is your lesson on minerals, ores, and fossil fuels. So we talked about the rock cycle. Now we're going to talk about why that's important for things that we use every day. So we're going to talk about where we get these things from and how we use them. So this is your bell ringer. This is kind of how we get our brains set in the right idea of what we're going to work with today. So you're going to answer these on Edpuzzle. It's going to pop up as soon as we finish this little section of video. You're going to answer, where do we use minerals, ores, and fossil fuels? And it's okay if you don't know, but if you think of some ideas, even if you put wrong ideas down, that's fine. I'm just trying to get you to think about where we use some of these things, okay? And the second one, can we live without minerals, ores, and fossil fuels? So those are your two questions. So take a second to answer those questions on Edpuzzle. All right, now that you've had a chance to answer those questions, let's talk about them. So the first one, where do we use minerals, ores, and fossil fuels? In all honesty, we use them everywhere, okay? Now, there might be some things that don't have all three of them, but we use them everywhere, either in the way we create something, what we're eating, how we're building these things. A lot of the plants and things that we use, like manufacturing plants, so like the places where people work, those are run by fossil fuels. So even if there isn't a fossil fuel used to create the thing we use itself, it was used in the process to create it or to power the machine or something like that, okay? All right, and number two, can we live without minerals, ores, and fossil fuels? No. All right, now you can say, oh, I could live without this kind of ore or a couple of these ores or maybe without fossil fuels. But currently, the way we run our society without minerals, ores, and fossil fuels, it would look completely different. The only one that I can say definitively we could likely find a way to get rid of and not have to worry about it would be fossil fuels. But minerals go into our bodies. They keep us healthy. They're in a lot of the foods we eat, the makeup we have, the medicines we make. So there are tons of places where we use minerals and ores, okay? Now, the fossil fuels, we'll talk about what that looks like and how we can kind of change the way we do things, and we could possibly live without those, okay? All right, so we are going to talk about minerals, ores, and fossil fuels today, all right? So these two pictures up here in the top left-hand corner, those are some examples of minerals. That's what they could look like. So a lot of the crystally things we talk about are going to be minerals. So a lot of the jewelry and pretty things that we have like for decorations on our shelves. Over here on the top right-hand side, there's just some pictures of some ores. We'll talk about why those are important and why they don't look like they would be super special. All right, and fossil fuels down here, we use these to kind of run our daily lives right now. So this is us using some fossil fuels, and this is how we get them out of the ground. So this picture on the left-hand side is us burning those fossil fuels to get energy. And this picture right here is how we drill down into the ground to get those fossil fuels up to the surface. All right, so the first thing we need to talk about when we talk about minerals, ores, and fossil fuels is their properties. So their properties are what make them absolutely flat out useful for us. So without these special properties, it would be nothing. It wouldn't really be worth anything to us. So there's two kinds of properties that can make something useful. It is a physical property, which means it is a property you can see without changing the chemical makeup of that material. So if I have a piece of paper and I tear it in half, it is still paper. The shape is different, but it is still paper, so that is a physical change. All right, now if I take a marker and color on something, I'm changing the color of it. That is a physical property. That is still going to be paper, even if I color it blue or color it yellow or color it green, okay? If I take a rock and break it in half, that is a physical property. Some rocks are harder to break than others. Some rocks are really easy to break. Some of them crumble apart when you touch them. So that is an example of a physical property. And the same thing if we talk about freezing and boiling. All right, so if I freeze water, it turns into ice, but it is still the same chemical makeup. It is still H2O. It is just now a solid form of H2O. If I melt that ice, I have water. It is still H2O. It is still that same chemical makeup. And if I boil that water, it's going to turn into water vapor, even though it's really hard for us to see and feel sometimes. It is still H2O. It is just in a different form. So those are physical changes. All right, chemical properties would be anything you can see by changing the chemical makeup of that property, of that material. All right, so if I take that piece of paper that I've colored all over and I burn it, that is a chemical property. I no longer have paper once I've burnt the paper, I have ash. All right. If I take that paper and dissolve it in some acid, it's no longer paper. Okay. So if I'm changing the chemical makeup of that material, of that paper, of whatever, then that is a chemical change. Okay. So chemical changes, you don't have the same thing afterwards, right? So physical change means it's still going to be the same thing. Chemical change means it is no longer the same object. Okay. All right. So now we'll talk about how they're created. So we've talked about the rock cycle. You know how these different kinds of rocks are created. Now we're going to talk about why that's important. All right. Minerals, ores, and fossil fuels are products of the rock cycle. It's fueled by the movement of Earth's plates, so it's constantly churning and moving things. So they're creating all these different things that we use here on Earth. And those processes give us everything here that we use to make paper, plastic, gasoline, our cell phones, our buildings, our medicines, our makeup, our hair products, the cups we drink out of, the hand sanitizer, all of it. Okay? Now, there are other materials that go into it that wouldn't be considered minerals, ores, or fossil fuels, but the minerals, ores, and fossil fuels are what give us the opportunity to use these other materials. So paper has minerals in it. It allows us to treat the wood pulp. So paper is made out of wood pulp. They take the wood and crumble it down and bleach it so it's white. And we add some minerals and things to it to give it different textures and to give it a different treatment or even to color it. So even though paper is not made out of just minerals, it has minerals in it that make it usable for us. Okay. So when we talk about everything's created with minerals, ores, and fossil fuels, it's not just with those three things. There are other things that go into it. But without minerals, ores, and fossil fuels, we wouldn't have some of those things that we use every day. Okay. All right. So now that we've talked about why they're important, let's talk about what they are. A mineral is a natural solid material found in the earth. All right. So minerals are what make up all the rocks we have here on earth. So if you go out there and kick in the dirt or pick up a rock, you have minerals in your hand. So each mineral has a special property that makes it really useful to us. Some of it is just really pretty. So sometimes the use that we have is just for making jewelry or just to create something that's artistic, that's pleasing to us, that gives us something nice to do or nice to think about or look at. Okay. So when we talk about the properties that are important, if we think about diamonds are really pretty and sparkly, and the light hits them just right and they can turn rainbow colors. That's what makes them look like they're glittering, because they change colors. All right. So diamonds are also one of the hardest materials that we know of here on Earth. So not only are they really pretty and do cool things with light, they're really, really hard. They can be sharpened by a diamond blade. So you can take diamonds and you can sharpen them, and you can use them to cut just about anything. So diamonds are really pretty and they're very strong. So they're really useful to us. So when we're talking about people that are trying to do fine details and like carving things, or a lot of the dental tools we have are actually made out of diamond as well. So when we talk about these things, it's not just one use most of the time. So there's usually a bunch of different reasons that we have for using a specific kind of material. Okay. And we'll talk about this a little bit more in depth later. So I'm going to have you do something later with this information. I'm just going to give you the basics right now. All right. Ores are rocks that are mined from the ground because they contain a valuable mineral. Okay. So if I know that, let's say, I know that granite in the ground runs next to gold, or they kind of run together. So if I find granite in the ground, I can pull that granite out and crack it open, and sometimes there's gold that's running through that same vein. Okay. Now, it's not always a metal that's in ores. Sometimes it's something else. But if we're talking about a rock that's really valuable to us, or has something in it that's valuable to us. So if we talk about like geodes, some of you have probably seen geodes. They look like a regular rock. You break it open, it's got pretty crystally stuff on the inside. So that would be an example of an ore, because it's got a valuable mineral in it that we can use. So the examples I've given you is iron ore, copper ore, and then this one right here. They're not always called an ore. Sometimes it has a specific name. So bauxite is the name of a ore that we pull out of the ground, and it's got aluminum in it. So you can call it bauxite, or you can call it aluminum ore. So either way, we're talking about the special material that comes out of it that we use. Okay? All right, and the last thing is fossil fuels. Fossil fuels are natural fuels that are made deep in the ground from the remains of living organisms. And these aren't something that's made quickly. Okay, so when we talk about minerals and ores, sometimes it only takes a couple of years for minerals and ores to reform, but it depends on what kind of mineral and ore you're talking about. But with fossil fuels take millions of years to replenish. So if we use a whole ton of them or we use them really quickly, we're going to run out of them. So that's one of the issues with using fossil fuels all the time. But they are really useful to us because if we burn them, they can give off tons of energy that we can harness. Okay. So the three most common fossil fuels, and I'm going to tell you what they're, I've got some pictures across the bottom. The three most common fossil fuels are something that probably all of you have seen or come in contact with because they're so super common. Okay. So charcoal. Coal is one of the main fossil fuels that we use. We use it in charcoal grills. You've probably seen it being burned in like a wood stove or maybe in a steam engine in a train. If you've ever been to Tweetsie Railroad, their train is a steam engine, so it runs off of coal that's being burned. This right here in the middle, that would be natural gas. So natural gas is a clear, odorless gas, and it's run through pipes to your house most of the time. If any of you have a gas stove or gas logs in your house, it is run off of natural gas. So that's a gas stove eye. So the only time we can see natural gas is if we are burning it. So it burns kind of a bluish red color. It's really pretty. But that's where we see natural gas. And right here, this is crude oil, what this guy's got in this jar right here. And it's really gunky and gloopy and kind of gross. And sometimes there are oil deposits in certain areas that are really close to the surface. So we don't necessarily have to dig for it. But most of those deposits that are really close to the surface, we've already used up. Okay. So when we're trying to dig them out of the ground, we use this thing right here. This is what we call an oil drill. So they drill down into the ground and they pump that oil out of the ground using that. Okay. So that's how we get these things. And we'll dig in and talk about where we use these things and how we use them just a little bit more later. So one last thing, I do want to show you this video on fossil fuels and talk about how we use them, and it gives you a little bit more information than what I was able to give you. Okay?
Fossil fuels. Fossil fuel is a term used to describe a group of energy sources that were formed from ancient plants and organisms during the Carboniferous period, approximately 360 to 286 million years ago, even before the age of dinosaurs. At that time, the land was covered with swamps filled with organisms and plants. As they died, they sank to the bottom of swamps and oceans and over millions of years started decomposing under layers of sand, clay, and other minerals. Different types of fossil fuels formed depending on the combination of organic matter, temperature, time, and pressure conditions while decomposing. There are three major types of fossil fuels: coal, oil, and natural gas. Coal was formed from ferns, plants, and trees, which hardened due to pressure and heat. Oil was formed from small organisms like zooplankton and algae, where pressure caused the more complex organic matter to decompose. Natural gas was formed by the same process as oil, only it was exposed to more heat and pressure, causing it to further decompose and turn into a gaseous form. Fossil fuels are sought after energy sources because they have a high energy density. They are the world's dominant energy source. Fossil fuels have a variety of applications from electricity production to transport fuels. They can also be used to make a variety of common products, from plastics to cosmetics to even some medicines. These resources have powered industrialization over history and continue to do so today. Fossil fuels can be an abundant and cheap, or in some cases, a scarce and expensive form of energy, depending on geographic location. For this reason, geopolitical issues arise due to scarcity caused by the natural geographic allocation of these highly valuable resources.
All right, so what this means is that there are political issues that come up because of the geography of the land. So they're talking about places that have a whole lot of oil and places that don't have a whole lot of oil. So if we're talking about somewhere that doesn't have a whole lot of oil and they're not friends with somebody that does have a whole lot of oil, but our whole world pretty much runs on fossil fuels, it makes things really difficult for the countries that don't have a whole lot of fossil fuels, not in their ground naturally. Now, in some cases, there are ways around it. There are places that have decided to go with renewables and use that. So like solar power and wind energy, things, hydroelectric power. So there are other ways that people were able to get power, but this is causing a whole lot of issues. So when we talk about like the oil conflicts and stuff like that, and people talk about, oh, gas prices are going up because we don't have a great relationship with a different country. Part of it is because we don't have a whole lot of these fossil fuels here in the United States. The ones that we do have are really hard to get to. So it wouldn't just cause issues for the environment. It would be issues for the people that live in those areas or don't live in those areas. It could cause a lot of problems. And we'll dig into that, the problems that come with that sometimes a little bit later.
Fossil fuels are considered non-renewable resources because they take millions of years to form, which means that once they are used, the resources will not be replenished in a human lifetime. The gradual depletion of the most accessible fossil fuel reserves have forced companies to develop technologies for extracting more challenging or unconventional reserves. In many cases, this means additional safety and environmental concerns as well as higher costs. Fossil fuels are also the largest emitters of carbon dioxide, a greenhouse gas which causes climate change. In addition, their production causes both environmental and human health issues. These concerns have triggered society to look at alternate sources of energy that are more environmentally sustainable and renewable. That's fossil fuels.
All right. So when we're talking about these things, we're talking about minerals, ores, and fossil fuels. We're talking about how we run our daily life. And sometimes things don't always work exactly the way we want them to. So we are going to talk about the pros and cons of a lot of the things that we use, not just fossil fuels. We're going to talk about the minerals and ores that we use every day and how sometimes that causes issues for certain people. Okay? So that explained a little bit more about fossil fuels. And I am going to remind you really quickly, when we talked about years, we talked about Earth's history. We talked about the history of the universe. We talked about how old it was. We talked about seconds and comparing it to something that's a little bit easier for us to understand. So if we say 1,000,000 seconds, that's around 12 days. So that's not a super long time. If you're ordering something from overseas, it might take that long to ship to you. But for right now, 12 days is really not that long. All right. If we say 1,000,000,000 seconds, we go from 12 days to 31 years. All right. I'm not even that old yet. I am not 31 years old. So for me, that's a really long time. I haven't even been alive that long. It's longer than my lifetime. Okay. So 1,000,000 seconds goes from 12 days to 1,000,000,000 seconds in 31 years. Okay. So million, billion, and then trillions. When we talk about trillions of seconds, we're talking 31,000 years, and it's 31,500 years. Okay. So it's a really, really big jump to go from 1,000,000 to 1,000,000,000. Okay. We talked about it before. I just wanted to kind of remind you that when we talk about how long it takes some of these things to form, so we talked about fossil fuels take millions of years, and we said that the minerals and ores can take anywhere from a couple years or a couple days, depending on how we form them, to thousands of years. Okay, so when we talk about how long it takes these things to form, we're not talking about a day or a week or something really short. We're talking about something that takes an extended period of time. Okay. All right, and that's it for minerals, ores, and fossil fuels.